Welcome back to Artisticoder. In our last video, we introduced one-dimensional dynamic programming, and now we're taking it a step further with two-dimensional dynamic programming. This approach is essential for solving problems involving grids, matrices, and multiple state transitions. If you're preparing for coding interviews, mastering two-dimensional dynamic programming will give you an edge. Let's dive in. 2D dynamic programming is an extension of 1D DP, but instead of storing values in a 1D array, we use a 2D table or matrix to track subproblem results. This is useful for problems where decisions depend on two variables, such as grid-based pathfinding, string matching, and resource allocation. To solve a 2D DP problem, follow these key steps. Number 1, define the subproblem. Break the problem into smaller overlapping subproblems. Number 2, identify the state. Determine how to represent the problem in a 2D table. Number 3, create a transition formula. Define how each cell in the DP table is derived from previous values. Number 4, initialize the base cases. Set up initial values in the DP table. Number 5, iterate over the table. Fill in the DP table using a nested loop structure. Let's solve the unique paths problem. Given an n by n grid, how many ways can you move from the top left corner to the bottom right corner, moving only right or down? Here's a solution that uses 2D DP. We create a DP table to store the number of unique paths at row I, column j. Then we update the table using the following rule. dp of ij equals dp of I minus 1j plus dp ij minus 1. Then the answer is at dp m minus 1 n minus 1. 2D DP is useful when a problem involves two dimensions of dependencies. Here are some common scenarios. Pathfinding problems, counting ways to move through a grid. String problems, comparing or modifying two strings. Subset problems, partitioning data into multiple groups. Game theory, computing optimal moves based on multiple variables. 2D DP can be tricky. Here are some common mistakes to avoid. Incorrect table dimensions. Ensure you correctly size the DP table. Forgetting base cases. Base cases must be set up properly. Inefficient storage. Optimize space when possible. Order of computation. Fill in the table in the correct order. Thanks for watching. Dynamic programming is a powerful tool, and learning 2D DP will give you an advantage in coding interviews. If you found this helpful, please like, comment, and subscribe. Donations are also appreciated and help support my work as an autistic content creator. Let's keep learning and growing together. And don't forget, we have a challenge live right now. Can you count how many nodes in a binary tree have exactly one child? Be sure to check out the challenge.